So let's talk about some ionic compounds. What is an ionic compound? Well, it's a compound that contains an ionic bond. Well, it doesn't really tell us anything. We need to look a little bit further here to figure out what an ionic bond is. And, an ionic bond is created when electrons are lost from a metal and gained by the nonmetal. That's what we just kind of mentioned as well in the last slide there. So another way of saying this, and this is really more the official way, I would say, is ionic compounds are made of metals and nonmetals. And even another way of saying this is that we've discovered that metals turn into cations and nonmetals turn into anions. So another way would be to say they're made of cations and anions. So let's go through some examples here. So what happens when we put sodium and chlorine together? So sodium is a group 1, it has a 1 valence electron. And chlorine is a group 7, it has 7 valence electrons. So they make a good match because sodium wants to lose that one and chlorine wants to gain one. So what we'll do is we'll draw sodium without any valence electrons because it's lost its one. And then we've drawn chlorine where it has gained one. And we've made our discovery that every time you put sodium and chlorine together, you are going to end up with one of each. And this happens to be our formula when you put sodium and chlorine together. You get sodium chloride. And that's the naming rules here as well. So firstly, you'll name the metal. The metal comes first. It's sodium, so you call it sodium. And then you name the nonmetal with an "ide" ending. So chlorine becomes chloride, sodium chloride. Let's try another one here, magnesium and fluorine. So magnesium is in group 2, and fluorine is in group 7. So this starts well. We can fill fluorine up, but the fact is that magnesium is still unhappy. It still has an extra valence electron. So we'll add another fluorine. And we can put that valence electron right in that spot. So if you draw this one out, it looks a little like that. We'll make it symmetrical. We'll put magnesium in the middle. And there is the shape of our molecule. And our formula of the molecule is we've got 1 magnesium and then 2 fluorines. So MgF2. And we go to name this one. Follows the same convention, magnesium fluoride. Last one here, aluminum and sulfur. Aluminum has 3 and sulfur has 6. So this starts well. We can put that one there and that one there per se. And then we'll add in another sulfur, and we can take aluminum's electron and put it there. But now we need another aluminum because sulfur's not quite filled up. And then we're almost there as we take that last one and put it there. And now we have done it. And this is starting to get a little out of control here. So our molecule looks a little something like that. Our formula is Al2S3, and that one is aluminum sulfide. This method started nice. It's starting to get a little complicated. So we do have an easier way of doing this, and it goes back to those stable charges on the periodic table earlier. So the crossover method. Let's just do an example, and we'll talk about how this works. So the last one we did was between aluminum and sulfur. So the first thing you do is you go to your periodic table, and you look up the stable charge of aluminum, which happens to be +3. Then you look up the stable charge of sulfur, which happens to be -2. Now, so how do we figure out how many of each element there is in our compound? So we're going to write aluminum first, and then what we do is we look at the number, just the number, we don't care about the charge, with the other atom, and it's going to come down and become our subscript here, Al2. And then to figure out how many sulfurs you've got, you just look at the number there, and it comes down, and it tells you you have 3 sulfurs. Aluminum sulfide. Now, we did just draw this one. If we flash back to that slide and remember this formula, let's confirm if we did it right. Sure did. There it is, the same formula. Maybe we should double check our other 2 examples as well. So this one was the magnesium and the fluorine. You look up magnesium stable charge, it's +2. Look up fluorine stable charge, it's -1. So how many magnesiums are we going to get? Well, we're going to get 1, but we're not going to write the subscript 1. By writing Mg, we know we have 1 of those ones. How many fluorines will we then get? The 2 comes down. We get 2. We get magnesium fluoride. Let's double check. MgF2. MgF2. That's what we got earlier when we drew it here. And lastly, sodium and chlorine. They each have charges of 1. So when you cross them over, they each get 1. Sodium chloride, NaCl. And that's exactly what we found here for NaCl. So a couple more examples to finish this off here. Magnesium oxide. So you need to look up magnesium's charge, and it has a stable charge of +2, and you look up oxygen's stable charge of -2. And your first thought might be, our formula here is going to be Mg2O2. Well, that's not really the case, because magnesium wants to lose 2, valence electrons. Oxygen wants to gain 2 valence electrons. So really, we just need one of each. MgO. So picture this as really kind of being reduced. It's like a fraction that got reduced to lowest terms, I suppose. But this also applies when you get the charges both being 3. Again, aluminum loses 3, phosphorus gains 3, so you only need one of each atom. The bottom line here is when your charges are the same number, whether they're 4s, 3s, or 2s, or 1s, you end up with one of each element in our compound. Magnesium carbide, Mg plus 2 and C minus 4. If you look up carbon, it's got a few positive charges in that box, but we're interested in its one negative charge because anions, the nonmetals, are always negative. And when you cross this one over, you get Mg4C2. Now, this one's not quite done. This is one of the few examples for ionic where we actually need to kind of turn it into lowest terms. We need to divide each of them by 2. And we get MgC2. And that ends up being our formula. Like I said, this won't happen very often, but just keep your eyes out for it.